Okay, so today's video is going to be on direct proportion. Okay, and we've covered this in the past, but obviously I'm going to cover things again. And firstly, let's just try to identify it from a graph. So, definition of direct proportion is twofold. The first one is they're in a set ratio to each other, two variables, which means if one doubles, then so does the other. If one triples, then so does the other. If one quadruples, so does the other. If one halves, then so does the other. And also the caveat is that when one variable is 0, then so is the other one, because otherwise they're not in direct proportion, they'll just be in proportion. So identifying on the graph, got to satisfy a few criteria. It's got to be a straight line, and it's got to go through the origin. The straight line shows that as one thing doubles, so does the other. As one thing triples, so does the other. As one thing halves, so does the other. And going through 0, 0 satisfies the criteria where one thing is 0, so is the other one. So let's have a look at our graphs. So straight line goes to the origin, so yes, it's in direct proportion. This one, straight line, goes to the origin, yes, it's in direct proportion. This one's a straight line, but it does not go through the origin, so it's not in direct proportion, but it is in proportion. This one, it goes to the origin, but it's not a straight line. So you can see as one thing doubles, the other one more than doubles. So it's not in direct proportion. And this one doesn't go through the origin. So that's a little bit about how to identify things from a graph. Let's have a look at a worded problem. So a machine fills 1,000 bottles in 5 hours. How long would it take to fill 1,200 bottles? So proportion questions can be done a number of ways. I think the easiest way is either just through sentences or ratio. I'll show you both ways. So if we want to do it in sentences, we would do 1,000 bottles in 5 hours. And I want to get to 1,200 bottles, 1,200 bottles. So I can't go directly there. But if I go down to 200 bottles, that will require dividing by 5. I can divide this by 5. And then to get up to 1,200, I've got to multiply by 6. So 1,200 bottles in multiplied by 6, 6 hours. So that's one way of doing it in sentences. Another way, it's pretty much the same way, but it would be with ratio. So 1,000 in 5 hours. Divide by 5 gives us 200. Divide by 5 gives us 1 hour. Times by 6 gets us 1,200, where we're aiming for. Times by 6 gets us 6 hours. So we could get to 6 hours either way. Okay, maybe you get a question and it's got a table and it tells you X and Y are in direct proportion. That means the ratio between them is going to be the same. So you can think of it as, well, from getting from X to Y, what happens? It triples. So let's triple it. Let's triple it. Let's triple it. And then getting from Y back to X, well, you're dividing by 3 is the opposite. So this one's going to be 50. So start to fill in the table. You might get asked to draw a graph to represent this. So if that was the case, hopefully you'd have more sensible numbers than this. But a graph has an x-axis and it has a y-axis. Let's adjust things so you can see it a bit better. And then we've got to plot some coordinates. So 5 across matches with 15 up, there's a coordinate, 6 across, 18 up, and so on and so on and so on. And you draw your line. If you've done it correctly and if it's in direct proportion, it would be going through 0, 0, and it would have these points labeled on it. You can create a formula to connect them as well. So that formula can be done in one of 3 ways. I think the first way is, let's think, we start with x and you triple it and you get y. So you could say that y equals 3x. So if you're looking for y, triple x. What if you're looking for x though? So x, you'd have to divide y by 3, which means we write it like this. And the last way of writing it is, if you have got x and y together, if you do y divided by x, that is always going to get you 3. So all 3 of those are formulas involving y and x, depending on what you're looking for. If you want to know what y is, use this one. If you want to know what x is, use this one. If you want to compare y and x, use this one. Okay, these have all been fairly easy numbers. Maybe we've got one with more difficult numbers. And if you've got one with more difficult numbers, perhaps there'll be a little picture of a calculator. So you got a picture of a calculator, which means I can use a calculator for this. How do I get my answers? And if you're used to just saying, oh, we'll triple this or double this, you look at this and okay, 12 doesn't go into 30, so I don't know. Maybe you add 18, and you start adding 18 and taking away 18, and it's wrong. Direct proportion has to be with timesing and dividing, not with adding or subtracting. So it's probably best if we create some sort of formula here. And like I said before, there are 3 forms of the formula, and one of them is going to be y divided by x equals, and we can figure this out with the first information. Just grab a calculator, and we're going to do 30 divided by 12, 2.5. Which means that if I rearrange this formula, if I'm looking for y equals 2.5x. So I can do this one. I can do 15 times 2.5, 37.5. And if I want to do this one, if I want to find x, just rearranging this in a different way. X equals y divided by 2.5. 40. So you can get easy ones using a bit of common sense, but when they get difficult, there's no reason why the same processes won't work. And things which direct proportion can be used for are exchange rates. If you've got double the amount of pounds, you can get double the amount of euros or dollars. It makes sense. If you've got double the amount of euros, you should be getting back double the amount of pounds. It makes sense. If you've got 0 euros, you can get 0 pounds. That fits all the criteria for direct proportion. So if you see a conversion graph for money, it might look like that. And you've got pounds and you've got euros. It also works for unit conversion. If you think about miles and kilometers, if you double the amount of miles, it's obviously going to double the amount of kilometers. And if you double the amount of kilometers, it's going to double the amount of miles. Makes sense. If you've got 0 miles, you've got 0 kilometers. Same sort of graph. I could just change that to say miles, can change that to say kilometers and it still works. It's only some units though. There's some units where it doesn't work. Some tricky ones like temperature conversion doesn't always work. So hopefully this has reminded you of direct proportion, and hopefully it'll enable you to have a go at today's exercise. And I will be available in the chat if you have got any questions. And apart from that, have a go and submit your work 5 minutes before the end.